Okay, welcome back to the fourth. Is it the fourth or the fifth video? Oh, I lost the count. Okay, welcome to the video where now I'm going to explain how you draw the graph of a logarithmic function from exponential. If you remember very well, in the previous video, I was explaining how to find the logarithmic equations, how to make the exponent the subject of the formula. So this time around, we're going to use that concept to forming the inverse function of exponentials, which are logarithmic. Okay, so now we have the general formula, which is f of x equals to a to the exponent x. When you're looking at this function, it's a general one. That's why we have a, but it can be represented by a number which can be 2 or 3 or even half, right? Then it has to be converted to or translated, or transformed to f of the inverse function of x, the inverse function of x, which is equals to log x to base a. So how? That's why I wrote the how there. How do we do that? The question is, how do I do that? Remember in the previous video when you were converting, or when you were making the exponent the subject of the formula? That's exactly how you do it. So in this case, there are going to be 5 steps. The fourth and the fifth depend on the question. But basically, there are 4 steps. The fifth one depends on the question. So now, if they gave you a question like this, let's say they gave you an example, can be if they gave you a question like f of x is equal to 3 to the exponent x, right? And they tell you to find the inverse function of this exponential function. If they tell you that, then you're gonna have to follow just 5 steps. The first one, remember, in all inverse functions, the first step, which is very important, guys, and there's a mark for it in your examinations, the first step is this. Now we're gonna say first step, you just write inverse, right? Then you do this and say y is equals to x, because an inverse function is nothing but translating, or reflecting, right? It's nothing but reflecting a graph above the line y equals to x. That's what you mean when you write this. Then the second step, remember, you're just gonna rewrite this. Where you see f of x, you just write y, because f of x is still y, right? So you're just gonna write y is equals to 3 to the exponent x. So then now you're gonna swap them. To be honest, this was supposed to have been written before this step, right? But even if you write it after, it doesn't matter, as long as you're gonna do it. So now you're gonna swap x with y and y with x, okay? Makes sense. So I'm gonna say where I see y, I'll write x, and say 3 to the exponent where I see x, I'm gonna write y. So now that I have my y as the subject of the formula, this is basically the inverse function. But because x is the subject of the formula, it ain't gonna look like an inverse function, right? It's not gonna look like a function if y is not a subject of the formula. So what am I gonna do? I'm just gonna make my y the subject of the formula using the logarithms, those laws of logarithms, okay? Logarithms, guys. So I'm gonna make y the subject of the formula and just say y is equal to what? Remember, you're gonna introduce the log, and what was the base will still be the base. Then the subject of the formula from the previous will be here. So now y is basically equals to log x to base 3. You see? So now this is not just y, it's an inverse function. Always remember to write this. The moment you make y the subject of the formula, write the inverse function symbol there. Then now you found it. Makes sense? So this is more like the fourth step. If they want you to represent your answer in this form, then this is where you end. But if they tell you to represent your answer in this form, you're just going to write f of the inverse x is equals to log x to base 3. Then there you have it, guys. There you have it. So I can make the second example. Let's say I have f of x is equal to, let's say I have 1 over 2 to the exponent x. Remember the first step, just to, or you can even just say y is equals to 1 over 2 to the exponent x. Just represent f as y. then say inverse. Inverse and say now y is equals to x. It means I'm going to reflect this graph above the line y equals to x. Then I'm going to do what? If I'm doing that, what am I going to do? I'm going to swap x and y. Where I see x, I'm going to substitute by y. And where I see y, I'm going to substitute by x. Then I'm going to say x is equals to half to the exponent y. Now, this is an inverse function, but does it really look like a function? Nah. So I'm gonna have to make my y the subject of the formula using logarithms. So if I make this exponent the subject of the formula, it's gonna be like this. Then I'm gonna say log. Remember, what was the base will still be the base. Then this will just be here. Makes sense? So now that I'm done, remember it's an inverse, so always put the inverse symbol. Or I can just represent it like this and say this is equals to log x to base half. Then I'm done. Okay? So this is how you actually convert, or how you represent the inverse function of an exponential. The logarithmic function is an inverse of exponential, and that's it. So now what I'm going to do now is to draw them. Remember, if you know how to draw the grade 11 graphs, it's going to be very easy for you to draw the grade 12 graphs. But if you can't, maybe I might record a next video for just grade 11 divisions, specifically for grade 11, but we'll see. We'll see. As long as you keep on commenting, sharing and stuff, then maybe, just maybe, I'm going to record those grade 11 revision videos. So now I'm just going to draw this graph. I'm going to first have to draw this one so that you can see, once you know how to draw this, you can automatically know how to draw this. So let me draw it. Let's say I have a small, beautiful, you see how beautiful my Cartesian plane is? It's very beautiful. It's beautiful. It's beautiful like all math students, because guys, I've never seen a math student who's ugly. I don't want to lie. And I'm not saying anything about any other student, right? I'm just talking about math students. I've never seen one. So yes, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative, 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 negative. This is the x-axis, this is the y-axis, right? So if I am to draw this, right? If I am to draw this, I will first have to find the x-intercept if it is there, right? So to get the x-intercept, I let y to be 0, and once y is 0, it means x-intercept it does not exist, because any base raised to an exponent something can never give you 0. So if I'm looking for the y-intercept now, for y-intercept, I'm just going to substitute 0 on x. I will say 3 to the exponent 0 is going to be 1. So my y-intercept basically is 1, right? And remember, I told you that a, which is something here, remember that the original was like this: f of x is equals to a times b to the exponent x minus p plus q. Meaning, this automatically means that a is the one that tells you the shape, whether you draw above or below the asymptote. This tells you whether the function is decreasing or increasing. So when b is greater than 1, your function will increase. And if b was half, your function will decrease if a is positive, right? So now that I see my a is basically 1, which is positive, my function will be above the asymptote. And my b is 3, which is greater than 1, my function will increase, right? So my function, and remember my asymptote, which is q, this is my asymptote. Here it's basically 0 because I don't see q. Therefore, my x-axis is my asymptote. So my function will go like this, and boom, then I'm going to go like this. The function approaches the x-axis on the negatives, which is your asymptote, and it goes further away on the positive x-axis. You can even test this by substituting 1 on this function and see the value of y. Just substitute 1. If I put 1 here, I'll say 3 to the exponent 1 is 3. Basically, the coordinate for 1 is going to be 1 and probably 3. Let's say it's there. Let's say there. It's not drawn to scale, I'm sorry. So it's going to be 1 and 3. Right? So I've tested it. Right? So once I do that, this is my function of f. If I want to draw the function of the inverse function, what am I going to do? I'm going to take everything that I've seen on this function and swap x with y. The first easy point to swap is this one. Where I see x, I'm going to write 3. And now where I see y, I'm going to write 1. So 3 goes here, 1 goes here. So let's see. 1, 2, 3. There's my 3 here. and now 1. There's my 1. So this point will be what? This point will be 3 and 1. This is the first point, right? And remember, I had the y-intercept. The coordinate of the y-intercept was 0 and 1. Now I will go for the x-intercept, which means I will go for a point, another point here, which is 1 and 0. I just swapped them. So the function will go here. It was going to the negatives of x. In the negatives of x, it was approaching the x-axis, which means in the negatives of y, it's going to approach the y-axis. You see, everything just swaps. So the function will go like this and go like this, right? And go to this point and just zoom. And that's it. So this function is your inverse. So you see how easy this is. So basically, this is the logarithmic function. Remember, it does what? It is a reflection above the line y is equals to x. So when you look at this and you look at this, you can see this is a mirror line. Ah, guys, these things are easy. We are passing. So to show that these things are easy, guys, I'm just going to draw this for you as courtesy. And you are going to draw this one and draw this one. Okay? So this is the end of it. Otherwise, all the best for the class of 2022 for the June examinations. I know you guys are writing today, tomorrow. It depends on what time you're going to watch this video. Is it going to be today on Thursday, or are you going to watch it on Friday in the morning? Because I know some of you are going to do that. But otherwise, all the best. And yeah, I'm dropping the mic.